On page 120, our book talks about some special properties that can be used to identify minerals. Because they're special, not all of the minerals have these, but there are some like magnetite that are magnetic. There are some like calcite. Right here, this is an example of calcite acting like something that is often called TV rock. All the crystals are lined up, and when you look through there, you kind of see a double vision. It's kind of a fiber optic effect. What's coming through one side shines out the other side. I have a piece of this in my classroom that I wish I would have brought home with me for the quarantine that I could have shown you. That's really neat. Some of them have ultraviolet properties. If you shine UV light on them, they will glow with an orange or a green. In calcite's case, it will glow red. If you get to go to Gorman Nature Center, they have a great display of really pretty minerals, some of them polished, some of them natural, and you take a look at what they look like in their natural state. And then when you push the little button, the white light goes off and the UV light comes on, and they glow in a different color. A lot of people are having fun finding rocks up at Michigan along the lake, and they're called euprolites. They're in the Upper Peninsula up there, and they are rocks that have been rounded by the water, but they also have a lot of minerals in them that fluoresce. So they're using UV lights to find cool things that look like glow-in-the-dark eggs along the beach, and that's really fun. One of my favorite properties of calcite is that it will effervesce. On our page that we have a little quiz the kids are working on, there is an acid test. So carbonate minerals like calcite and dolomite, they have a lot of calcium in them, and it will bubble or effervesce when you put acid on it. So first we are going to try that using vinegar. So this is something that you have at your house probably. And right here I have just a piece of limestone out of my driveway. And I'm just going to pour quite a bit of that over there so we can see some, oh yeah, quite a bit actually. A little hard to look through here. And we should see some bubbling. See that little bubbling action happening there? That is the effervescence that you will see as the calcium is bubbling out of vinegar. Okay, now we're going to take this limestone from the driveway and we are going to test it with the acid test by dropping it into some stronger acid than the vinegar. Vinegar is acid, but it's a weak acid. This is hydrochloric acid with some other things in. If you want to know exactly what it is, some of you may remember us mentioning it in class. I will send a reminder to your parents and let them know what it is in case they want to let you try this at home. But we do need parent permission. So I'm going to drop that right in there. And you can see that it really effervesces. We get a lot more of a reaction than we did with the vinegar. This is a lot more fun. Because it's a stronger acid, the chemical reaction is happening much faster. This is something that you would want to have on safety goggles for. Make sure that you have good ventilation, because if you get this in your eyes, nose, mouth, on your skin, there are some safety concerns because hydrochloric acid is not a toy. That's really a lot of fun to watch. I'm going to take some of these smaller ones here. I have some in a bottle, and we will drop it down in there. It's kind of fun to watch it do that as well. This is one of my favorite lessons, and I'm really sad that we did not get to do this together. After I let your parents know what this is, maybe this is something that you can try safely at home with parent supervision. It has been a few minutes and we're checking back on the hydrochloric acid with some pieces of limestone in it. And you can see that that reaction is continuing to go on and it's continuing to effervesce and caused this bottle to overflow. This bottle was about 3/4 full of hydrochloric acid solution, and now it has overflowed. me a little mess while I was in the other room. Luckily, it's not a danger. Nobody was sitting right here to be burned by this. But this is why we need to make sure that we have adult supervision. You would not want to put a cap on this as it effervesces and it is releasing all of those bubbles of carbon dioxide. That would build up pressure. So this is definitely not an activity. That is a toy, not for little kids. We don't want anyone to get hurt, but it is a really cool science activity to see. A little more time has elapsed and we can see that the chemical reaction is still going on, although it has slowed down dramatically. Quite a bit of, like this much of our hydrochloric acid has bubbled out and overflowed over the top. The bubbles that are coming up are carbon dioxide. You can see kind of dancing around here like a lava lamp, some little pieces of black. Those are something that was in the rock that is being released as the carbon dioxide bubbles out and the calcium dissolves, much as sugar would dissolve in water, and becomes part of this hydrochloric acid solution. We've gotten a little bit of a color change. It looks a little more gray blue than the bright blue that we started with. And this lesson on using effervescence to identify the mineral calcite has kind of morphed into another lesson on chemical weathering. So what we're seeing now is that the rocks that I dropped in there, the limestone rocks, are getting smaller and smaller and smaller. But because of the conservation of matter, law of conservation of matter, we know that they did not disappear. They have just changed. So some of them is changing into a gas and some of them is going into solution. And if we let this evaporate, if I leave this sit here for days and days and the water evaporates out of it, then what will be left is some sediment that's on the bottom that did not react to the acid. And then the calcium, when there's no water left for it to be suspended in, will go back into crystal form, much like this calcium. This came out of a stone quarry up by Lake Erie, and what you see is a big chunk of limestone. That's what they are quarrying there, limestone for construction and for driveways. And there is a lot of calcium in there, and it formed in this very same way. When there were ancient oceans here covering Ohio, there was a lot of calcium dissolved in the water from the shells of the animals that were living in that ocean, and as they came out of solution, they formed these beautiful crystals. So if we leave this long enough, we will get some crystals back. Not quite this beautiful because these took hundreds, possibly thousands of years to form, and these will grow pretty quickly over a couple of days or a couple of weeks, but we would get that effect. Don't really see anything happening too much in our bottle here anymore. The reaction seems to be kind of over, so I am going to pour this out. And we can see that we do have, where's the little camera? We do have sediment in the bottom there. Those are little pieces of the rock that did not become part of the solution. So that's not calcium. That's why it had a gray color. There was some dark stuff in there. Calcium is white. And as we look here, we can see we have some sediment on the bottom. And these rocks are definitely smaller than they were before. You've seen some of this chemical weathering happening before, where acid rain is eating away the calcium that is in the marble tombstones. If you go through a cemetery and you see the older tombstones and it's hard to read them, or you visit somewhere that has some old buildings and they've worn away, it's because there was calcium in those rocks that has been eaten away by the acid. And that's why today, when we want to memorialize someone, we use much harder granite to make our stones out of. They are not bothered as much by the weathering.